Hello everyone. Now we are going to study about conic sections. The definition of conic section is the locus of point moves in a plane such a way that the ratio of its distance from fixed point, that is focus, to a fixed straight line, that is directrix, is always constant. So in the picture the straight vertical line is directrix, and in the directrix we have M and C center point. So the horizontal plane, in the horizontal plane we have a focus. With help of that focus and directrix M, we used to draw a conic curve. So it should be fixed straight line is called as directrix. Fixed point is called as focus. So here in the pic we are seeing the circle, ellipse, parabola and hyperbola. So circle means eccentricity E is Vf divided by Vc. In case it is ellipse means the eccentricity less than 1. In case it is parabola means E equal to 1. In case it is hyperbola means E greater than 1. Now we are see about the applications of conic section. So we were seeing the football ground. So it's a shape of ellipse. So auditorium, the shape of ellipse. Now we'll see what are all the ellipse, parabola and hyperbola, how we used to draw. Just listen the video around 5 minutes.
In this module, you will learn about conic sections. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular
cone.
A double right circular cone consists of two cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base, and its axis is always perpendicular line from the center of the base to the vertex.
That's called
the
vertex.
The perimeter of the base is called the directrix.
That pink line is directrix.
The lateral surface of a right circular cone is called a nap.
The surface.
A double right circular cone has two naps. The nap above the vertex is called the upper nap.
Upper nap and down.
And that below the vertex is called the lower nap.
Lower nap or bottom.
Also, the angle between the generator and the axis is called the vertex angle. Conic sections.
Now we'll see what is a conic section.
If a plane intersects a double right circular cone, we get two-dimensional curves of different types.
Now we are seeing the three-dimensional.
These curves are called conic sections.
We need to draw in 2D, two-dimensional section. So the green,
depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways.
The green sheet is cutter section.
Ellipse.
First we'll see the ellipse, how they are cutting.
When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse.
Ellipse, full circle.
When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola.
Next, parabola. The cutter green section, how it's look.
When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone.
The same.
Hyperbola.
A equal to B. Next, hyperbola. How the green
the plane
cutter
intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle.
Yeah, A equal greater than equal to B.
If the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves. Degenerate conics.
So how they are degenerating
If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point, the parabola becomes a line, and the hyperbola becomes two intersecting lines. The figures so obtained are called degenerate conics. In this module you have learned
so here we were
that when a
seeing
plane intersects a double right circular cone,
two-dimensional curves called conic section are formed here. And also there are three types of conic section: ellipse, parabola and hyperbola. Yes, when the double right circular cone is cut by the plane so that the angle between the plane and the axis is greater than the vertex angle, the ellipse is obtained. When the plane is perpendicular to the axis, the ellipse changes into a circle. Yeah, it will change. If a double right circular cone is cut by a plane so that the angle between the plane and the axis is equal to the vertex angle, the parabola is formed. If a double right circular cone is